A is the point negative 3, 2, B is 2, negative 3, and C is 12, 7. They're 3 points in a plane. We want to show that the triangle ABC is right-angled. So if I say that A is negative 3, 2, and I draw A here, B is going to be at 2, negative 3, so that's 5 across and 5 down, so that's going to be just here. And C is at 12, 7, so that's going to be 10 across and 10 up. And so, without drawing it completely accurately, I think that I have a reasonable chance of seeing there that if there's a right angle, it's going to be this one just here. So the vector AB is going to be 5, negative 5. The vector BC I can see is going to be 10, 10. And if we do 5, negative 5, dot 10, 10, we get 50. Take away 50, which is 0, which shows that this one is a right angle. So if it's a right-angled triangle, we can just use a half times base times height. So the base is going to be the length of BC, so that's the modulus of this vector, which is the square root of 200. And then the height would be the magnitude of this vector, so that's root 25 plus 25, so root 50. So that's going to be a half times the square root of 200 times 50, which is 10,000. The square root of that's 100. So that is going to be 50 square units. Find the coordinates of the point D that divides BC in the ratio 7 to 3. So that's going to go sort of here. So we want the position vector. To get there, I'm going to go from O to B and then from B to D. So the coordinates of B, 2, negative 3. And the ratio 7 to 3 has got 10 parts. So we want 7/10 of BC, which is 10, 10. So that's going to be 2, negative 3, add 7, 7. So that's going to give us coordinates 9 and 4. And finally, D is the point with coordinates 12, negative 13, and it's a point in the plane. Show that A, B, and D are collinear. Well, we already have AB from up here. What's BD? So to go from B to D, so 2 to 12, that is 10. And negative 3 to 13, that's negative 10. And we can see that 5, negative 5 doubled is 10, negative 10. And that shows us the points are collinear. In other words, what we're showing here is that twice AB is equal to BD. In retrospect, I probably shouldn't have called this point D and this point also D, so I'm going to actually change this one to E. So when you get your copy of the practice test, it will have E rather than D there.